What we'll do here is take a look at how to draw the ray diagrams for a converging or concave mirror. First thing we'll need is the center of curvature, which is really the spherical radius of the mirror. And of course, halfway between the center and the mirror itself, we're going to find the focal point. And so the focal point is right there. Those are two very important points. Now, here's our object, and it's a certain height. It has a height HO for height of the object. And of course, in order to find out where the image is, we do three lines. We really only need two, but it makes a better diagram with three. So the first line is we draw parallel to the principal axis from the tip of the object to the mirror. It always reflects through the focal point. So there's our first ray, and we'll join all these three rays up after. Now the second ray we draw is from the tip of that object through the focal point. And so we go through the focal point, and of course, since it's gone through the focal point, it will reflect parallel to the principal axis. And of course, it's going to intersect with that first ray we drew. And the third ray that we draw, which is not entirely necessary, is through the center of curvature. And of course, it always reflects back on itself. And so now we have those three rays. Let's just draw those. And the first ray, of course, the blue, through the focal point, the second ray through the focal point and then reflecting parallel, and the third ray through the center of curvature. Notice they all reflect and can be joined at that final point. And of course, that's where the tip of the image will be. You'll notice some of the characteristics of this image. Number one, it is inverted. Because it's inverted, that makes it a real image, all right, which could be then shown on a piece of paper. The other thing is that it's larger than the object, and therefore it's being magnified. And of course, there's mathematics that you can use to find out what the magnification is. Now, if we move the object beyond the center of curvature, the same three rays have to be drawn, but we'll see a different result. So here's our object. Now, this time it's outside the center of curvature. Let's draw the three rays. One is parallel and then through the focal point. Another one is through the focal point and then parallel. And as you can see, that's all we really have required. Where those two lines intersect, that's where our object or our image will be. But the third line just verifies that. Through the center of curvature, it intersects at the same point. And this is where our image is going to be. Notice this time it's still inverted, therefore it's real. But in this case, it's a little bit smaller than the object. The image is inverted, smaller, and real. And here's another scenario where you have the object is very, very close to the mirror, inside the focal point. Let's see what happens here. This is a little more difficult, and you have to really pay attention to these ones and practice them up. So the first one is we draw a line parallel to the principal axis, and then it's reflected through the focal point. The second one is, of course, as if it were coming from the focal point, and then it will be parallel. And then the third one is through the center of curvature. Now notice that these three lines don't intersect on the left side of the mirror. But if you extend those three lines, okay, then of course we extend them beyond the mirror or behind the mirror, and those three lines intersect at a point behind the mirror. And if we draw the image there, we notice some of the characteristics of the image. First of all, it's not upside down, it's right side up. And the fact that it's right side up means it is a virtual image. All right, real images are always upside down. Virtual images are always right side up. So this is a virtual image that is larger than the object. All right, so it's been magnified. And of course, looking into a spoon and looking at your nose reflected on the spoon, you can see these different types of images. As you move further and closer to the spoon, you see sometimes you'll see a magnified image, and sometimes you'll see a smaller image that's upside down, and sometimes you'll see a larger image that is upside down, depending on where your nose is relative to the focal point of the spoon.